Okay, everyone. So this is going to be part 2 of your spring 2021 final exam review of your study guide. So we're still in Unit 1 and we're on skill number 4, calculating molar mass. And so as a reminder, molar mass of a single element can be found from your handy dandy periodic table, and the molar mass of a compound can be determined by adding the molar mass of all the elements in your formula. So as a reminder, when we're talking about an element, we're just talking about like silver, for example, or carbon or hydrogen, just a regular old element. But when we're talking about a compound, that would be something like silver nitrate, where you have multiple elements together. Now, the molar mass is equal to 1, that should just say mole, not moles, of the compound. So molar mass is the number of grams always equal to 1 mole of your compound. So if we want to find the molar mass of these, I'm going to show you an example of these two and not do all 4. But if you need to check your work for the other 2, you can leave a comment below the video, and I'd be happy to check your work for you, or you can ask me in class. So for C3H8, what you need to do is you need to split out your elements. So we have carbon and we have hydrogen, and we know that they're both separate elements on the periodic table because they have capital letters. And then we list how many of each atom we have, and we know that we have 3 carbons and 8 hydrogens based on their subscripts. So I'm going to write my 3 and my 8 next to my element. And now we need to multiply by the molar mass of that single element by looking at our periodic table. Now, when you look at your periodic table, the carbon is number 6 on the periodic table, and it has a molar mass of 12.01. And hydrogen is number 1 on the periodic table and has a molar mass of 1.01. So those numbers at the bottom, sorry, I don't know why the pen was so weird on that arrow, that is what you use here. So carbon will multiply by 12.01 and hydrogen by 1.01. And so we use our calculator, or if you're good at math and you can do that in your head, then you can do that. But 12.01 times 3 is 36.03, and 8 times 1.01 is 8.08. And then again, it said that the molar mass of a compound can be determined by adding the molar masses together. So then our last step would be to add them together, and you get, let's see, 44.11 grams per mole of C3H8. Now what that means, because remember, we can use molar mass just like mole ratio in a T-chart for conversions, is what they're telling you is that 44.11 grams of C3H8, like if you weigh that out on a scale, that is 1 mole of your compound. Okay, because remember, the mole is the unit we use to count things. It's equal to Avogadro's number, 6.02 times 10 to the 23. And they all weigh different things. So just like 12 donuts is going to have a different weight than 12 people, but they're both 1 dozen, 1 mole of a particular chemical is going to have a different weight or mass than 1 mole of a different chemical. So for this one, this other example, if we look at aluminum sulfate, this one's different because it's got a number outside of the parentheses, that 3. And what you need to remember to do is when we're looking at that number, you have to multiply that number to the S and the O because inside the parentheses, because it's saying SO4 is a polyatomic ion and you have 3 of them in this compound. So you have 3 of everything that's inside. So when we split up our elements, that is a lowercase l, not a capital I. So if you're ever confused, just ask your teacher and we'll be happy to tell you that it's a lowercase l. So we have aluminum and sulfur and oxygen. and we count how many we have. We have 2 aluminums, and we have 3 sulfur atoms. Now that's because there's an invisible 1 here. Chemists are kind of lazy. We don't write 1s. And so 3 times 1 is 3. And so for oxygen, we have 4 oxygens inside the parentheses, but we multiply it by 3, so we have 12 of them. And then we look at their mass on the periodic table, and we see that aluminum is 26.98, sulfur is 32.07, and oxygen is 16. And I'm not going to lie, I don't have my periodic table in front of me right now. So if I accidentally messed one of those molar masses up, someone tell me in the comments below the video. That way I can fix it later. But 2 times 26.98 is 53.96. 3 times 32.07 is 96.21. And 12 times 16 is 192.00. Your molar masses always keep 2 numbers after the decimal, which is why I'm including those 2 zeros. And then we add them together. And I don't want to do that in my head, so I'm going to use my calculator. And that will give us 342.17 grams per mole of aluminum sulfate. Now, again, remember, what that is saying is that if you have 1 mole of aluminum sulfate and you were to count it out and put it on a scale, it would weigh 342.17 grams. So molar mass, by its very definition, is always equal to 1 mole, no matter which chemical you're talking about. They're going to have different masses. The grams is going to be different, but the 1 mole stays constant with molar mass. And so we can use molar mass to make conversions between grams and moles of the same substance. Okay, so we can use it to make conversions. And so this was skill number 5 that we learned in Unit 1. And so we know when you're looking at a problem that you're going to need your molar mass if what you're given or what you're looking for has grams with that chemical. So if we look at question 1, it says how many moles of aluminum sulfate are in 450 grams of aluminum sulfate? And so what you need to do is first label what you're given and what you're looking for. So what we're given in this problem is that 450 grams of aluminum sulfate. That's our number. So we have 450 grams of aluminum sulfate, and you can leave out the word of when you're writing down your given. And we know we're looking for, it says how many moles of aluminum sulfate. Now, we already learned that if our chemicals are different, that we need mole ratio. So when I double check my chemicals, these are the same. And since they're the same, that means I have no need for a mole ratio, right? I don't need them. But what I do see is I see this G for grams. And so that means that I need the molar mass of the chemical that is right beside it, which is aluminum sulfate. Now, luckily for us, we already calculated this up here. We calculated our molar mass. And so what we're going to do is we're going to use that number as a fraction. So that would be 342.17 grams of aluminum sulfate over the 1 mole of aluminum sulfate. And I know it's tempting to not write out your chemical, especially when it is like as long of a chemical formula as aluminum sulfate has, but you have to use your units and your formula in your T-chart. Otherwise, when we get to longer T-charts and ones that are more complicated, you're more likely to make mistakes. And remember, we can also flip this fraction in our chart if we need to. So now that we have our fractions written for our problem, we can actually set up our t-chart. And remember, what you're given always goes in the first square. So we put 340. Oh, wow. Good job, Miss Nichols. We always put our given. So 450 grams of aluminum sulfate. And I did not leave myself enough room there. Okay, so 450 grams of aluminum sulfate. And whatever unit and chemical we have here, so grams, aluminum sulfate, has to appear at the bottom in order for the t-chart to work. Okay, if these two things do not match, then your t-chart is set up incorrectly. So when we look at our fractions, we see that the grams of aluminum sulfate is at the top of our fraction. So we're going to have to flip this fraction. We're going to need to put the 342.17 grams at the bottom and our 1 mole of aluminum sulfate at the top. And to double check that my t-chart is set up correctly, I can look at my units. I see that I have grams of aluminum sulfate in my numerator and my denominator, so those correctly cancel out. And I look at the unit and chemical that I have left over. When I compare it to what I'm looking for, they match. And so that means that I'm done. Hooray! And we can just put it in our calculator. So remember that we multiply by what's at the top and we divide by what's at the bottom. So this would be 450 times 1 divided by 342.17. And since I was writing that, I couldn't actually type it into my calculator. So 450 times 1 divided by 342.17 will give you 1.32. It really gives you 1.315135575, but we round. We always try to keep two numbers after our decimal. So the 5 will make the 1 round up, and our units will be moles of aluminum sulfate. And that is our final answer. Now that you have seen an example, I highly recommend that you pause the video and you try question number 2 on your own. And when you press play again, you will see the answer on the screen and you can check your work. Now, you're not going to see the work for it, but you will see the answer. So press pause, try question number 2, and then press play when you're ready to check your answer. Okay, so if you've pressed play, then you can see your answer now on the screen. So question number 2's answer is 527.07 grams of copper nitrate. Now, if this is not what you got, I recommend either posting a comment in the video below or in the comment below the video explaining what you did, or come find me in class and I can look over your work and help you. But one thing, always double check your molar mass. Make sure you calculated the molar mass of copper nitrate correctly and that you counted. Remember that you have to multiply the 2 by both the nitrogen and the oxygen. So you should have 2 nitrogens and 6 oxygens. And then double check the setup of your t-chart. Make sure that your units cancel out and all of that. And if you still can't figure it out, then maybe ask someone for help to see where you went wrong. So skill number 6 is actually a combination of skills 5, where we do conversions with molar mass, and skill 3, where we do conversions with mole ratio. So where you need a conversion with both. So we know that this is kind of just a review at this point, but if your chemicals are different, you need a mole ratio fraction in your t-chart. And if the chemical has a G next to it, then you need the molar mass fraction. And so if you have a problem that has both, you're going to need those things. Now, always remember that when you're doing the molar mass is always of the chemical that the G or grams is next to when you label what you're looking for and what you're given. Because, for example, in this problem, it says, in the following reaction, 1 mole of nitrogen gas plus 3 moles of hydrogen gas produces 2 moles of ammonia gas. How many grams of hydrogen will be needed to make 1.36 moles of ammonia? And so when we label what we're given and what we're looking for, what we will see is that we are given 1.36 moles of NH3 or ammonia, and we're looking for grams of hydrogen. Now, we see right away that my chemicals in each are different. And so because they're different, that is what tells us that we need to use a mole ratio in our T-chart for those two chemicals. And we also see that I have a G for grams. Now that means I need the molar mass. Now for this problem, we need the molar mass of hydrogen, but there is not a G for grams next to ammonia, so you do not need to calculate the molar mass of ammonia. In this case, we will only need two fractions. We'll need our mole ratio and we'll need the molar mass of hydrogen. Those will be the only two things. So if we go ahead and write it out, okay, because we want to write out everything we need. If we go and let's start with our molar mass. So with the molar mass of hydrogen, okay, we know to calculate it, we list our elements, and this one's easy because there's just one element, it's hydrogen. There are two of them. We multiply by 1.01, and we get 2.02 grams per mole. Now remember, show all of your work, because I can't tell you how many students have written 2 times 1.01 equals 1.01. And if you show your work, I can see, oh, they just made a real simple mistake by forgetting to actually multiply. And then you can still get a ton of partial credit. In fact, almost all of it in your problem. And so we can write this as a fraction. So 2.02 grams of hydrogen over 1 mole of hydrogen. And then we also know that we need our mole ratio. And our mole ratio comes from our coefficients. If you didn't watch the video and you're not really sure about mole ratio, check out the part 1 study guide review video. And our mole ratio comes from our coefficients. So we have ammonia and we have hydrogen. We can ignore the nitrogen because it's not a chemical in what I'm given or in what I'm looking for. And I can say, okay, 2 moles of NH3 over 3 moles of hydrogen. Now remember, for both of these fractions, we might need to flip them. Okay, keep that in mind. They might need to be flipped. We're not sure yet. We know that we need to use that fraction. We just don't know how we need to use that fraction until we set up our T-chart. So when we set up our T-chart, we always take what's given and we put it in our chart first. So we have 1.36 moles of NH3. And when we do that, we know that whatever we have here has to show up at the bottom. So I have to have a fraction that has moles of NH3 at the bottom. Now, we only have two options. I can use my molar mass fraction, or I can use my mole ratio fraction. So if I look for the words of mole NH3, it is only right here. And in fact, it's at the top, which means I'm going to have to flip it for this fraction. I'm going to need to put 2 moles of NH3 at the bottom and my 3 moles of hydrogen at the top. So now that I've already used it, I can't use it again. And I see that these units are going to cancel out and have moles of hydrogen. Well, that does not match what I'm looking for. So that means I'm not done yet. And I know I'm not done because I still have one more fraction that I need to use. So I set up another line and I say, okay, if I have moles of hydrogen here, the pattern still repeats itself. That means moles of hydrogen needs to be at the bottom. So I go looking for my fractions and I say, okay, technically I see mole of hydrogen and mole ratio, but I've already used that. I can't use it again. So the only other place I see it is in my molar mass, which is good because that's the fraction that I haven't used yet. And it's already at the bottom, which is convenient. So I put 1 mole at the bottom and my 2.02 grams of hydrogen at the top. So remember, our math stays the same. If the number's at the top, we multiply. If the number's at the bottom, we divide. Oh, and our units, moles of hydrogen cancel out with moles of hydrogen. Grams of hydrogen matches what we're looking for, which is great. So that's how we know we're ready to use our calculator. So again, if I want to write out, okay, how do I know what to put in my calculator? It's going to be 1.36 times 3 times 2.02 divided by 2 divided by 1. And honestly, you can do the multiplication and division any order that you would like, as long as you, 1, don't forget a number, and 2, always put your given in your calculator first. So again, we would put this in our calculator, always start with our given, 1.36, and then we can multiply by 3, multiply by 2.02, divide by 2, divide by 1, and that gives us 4.12, and my only units left are grams of hydrogen. And that is our final answer. And that is the end of your part 2 video for your study guide review. Part 3 will start with the answer for question 2. So if you want to go ahead and do that problem and then go to the next video to see the answer.